Hello everyone, hope you're doing good. Welcome back to my channel. Today we are at day 29 of the October Daily Leetcode Challenge, and we again have a question around metrics. And this time it's one of my favorite questions. This is that kind of question which you can be very confident if you get this kind of questions in interview, because there are so much to optimize here. Because see, whenever you are in interview, after trying the brute force approach, there should be something where you can optimize, right? This is such a question where you can optimize the way you want it. Okay, there are so many optimization steps available in my approach also. I will show you one of the good approaches, then after that I will show you another more optimized approach. So coming to today's question, it's a middle level question. It's around the topic of matrix, and I think I have already given you the hint. Whenever the matrix comes and whenever a traversal related thing comes, always DP will come in. Okay, so this is 2648, sorry, 2684. Maximum number of moves in a grid. Okay, you are given a zero index m cross n matrix called grid, consisting of positive integers. You can start at any cell in the first column. Okay, so the idea is very clear. They are asking you to start from the first column. So basically 2 5 3 10. Among these you can start from any one of them. Okay, first column of the matrix and traverse the grid in the following way. Okay, from the cell row comma column, you can move to any of the cells. Okay, so I think this will be making the things complicated for you to understand, but let me give you in a very simple approach. Okay, so what that means, suppose this is my matrix given to me. Okay, suppose this is the matrix given to me. Okay, let me zoom in. Okay, this is the matrix given to me. So suppose I am at 5. Okay, I have three options now. Okay, what are the three options? Either I can go to 4. Okay, that is the element direct next to it. Okay, I am at 5, I can go to 4. Okay, where I am currently, I am at 5, I can go to 4. Okay, this particular 4. This is the first option. Other option is I am at 5, I can go to this 4. Okay, yeah. Other option is I am at 5 and I can go to this particular 4. So these are the three options which every element will have. Okay, so what they're trying to say is, let us say you are at a particular column, at particular index I comma ag, okay, I comma j, let us say. Okay, so thing is, the next move should take you to the next column. Okay, so definitely, okay, let me quickly write this and show you. This will be making the thing very clear. Currently you are at I comma j, right? Next step will definitely take you to I plus 1, sorry, j plus 1. That is very clear, but what should be I? So I can be either next of that is I can be this thing. Okay, I can be, it can be I comma j plus 1, or it can be I plus 1 comma j plus 1, or it can be I minus 1 comma j plus 1. Okay, these are the three moves possible. Okay, the same thing they have given it here. Let me reduce the zoom now. Okay, yeah, the same thing they have given here. I hope you understand what it is. So if you are at 5, then you can go to the 3/4 which are around it. Okay, you can also think of it as, if you are at 5, you can go to the adjacent cells in the next column. Okay, that is this 5, the 5 4 above that. Sorry, if you are at 5, you can go to 4, the 4 above that, and the 4 below that. Okay, as simple as that. And let us say if you are at 10, you can go to this particular 4 and you can go to this 9. Okay, as simple as that. Yeah, these are the values. Okay, such that the values of the cell you move to should be strictly bigger than the value of the current cell. Okay, this is something very important. That means, let us say if I am at this particular, okay, if I am at 10, okay, I cannot move to this 4 because this is less. Okay, it is less than that. Similarly, I cannot move to this 9 again because it is less. Okay, that is the basic idea. Okay, this is the only constraint we have. Okay, what are the three cells through which we can move to? Okay, other than that, the element to which we are moving to should be strictly greater. Strictly greater means it should not be equal to the current element. Okay, it should be strictly greater than the current cell, that is the current value. Return the maximum number of moves you can perform. Okay, so here we are talking about the maximum number of moves. Sometimes they will also ask the minimum number of moves. Okay, let us quickly see the one of the examples first of all here. So if you see here, they have highlighted one of the answers here. I will give you another answer also. This is not the only answer we have, but the idea is again same. Whatever be the number of answers, you have to give the maximum number of moves possible. Okay, so see, there are four values highlighted here, but the answer is divided because 2 to 4 is considered as a single move. Okay? Similarly, 4 to 9 is a single move, 9 to 11 is a single move. I will be telling you one more such answer. Okay, but for that we'll have to, you know, we'll have to wait till I do the dry run. Okay, this is another example. Here the answer is 0 because here when I am at 3, I cannot move to any other element. Okay? That is, see, the possible elements are 2 and 1, but I cannot move to any one of them because they are less than 3. Okay, so only when I am in this particular 2, I cannot move to 2 1 and 1. Okay, because the next element has to be strictly greater. Remember that. Similarly, when I am in this particular 1, I cannot move to this one or this one because the next element has to be strictly greater. That's why I cannot make any move from when I am at one of the cells, when I'm at one of the cells of the first column. That is why the answer is 0. Coming to the constraints, constraints are in this particular range. That is the, I can say the number of rows and the number of columns can be up to 1,000. Okay, and starting from 2. That is, it will never be a matrix of a single element. Definitely, it will have more than one element. That's why the starting value is 2. And yeah, You can also go through the hints, but this is a very very standard question. Let me tell you. Uh, uh, Let me tell this very frankly. If you are trying for an interview, this or anything somewhat related to this will definitely come. So if you are a fresher, if you are in the fourth, in your third year, and or if you are in the starting of a fourth year, definitely take it in writing from me. This particular question, or sometimes a question similar to this, will definitely come till you get a company. Okay. I mean, what are interviews that you face? One of those interviews will be definitely based on this. I'm talking about the face-to-face live interview. Okay, not the coding assessment rounds. This kind of questions will be in the face-to-face interviews, because the interviewer will see like what kind of organization you can think of. And here in the particular question, there is a lot of approach. Okay, there is a lot of possibilities also for optimizations. Will come through that. I will also show you two optimizations in this particular question. So what should be my solution? So again, if you have been watching my videos, you will be definitely, I'm sure that you would have done this question on your own itself, because this particular thing we have solved so many times. Okay, question similar to this. So I'm damn sure you'll be knowing what my approach will be. I've also given you so many hints that it will be a DP. Okay, that is a dynamic programming approach. So why I am using DPC? Idea is very simple here. See, try to analyze it. Okay, what the idea here is. Okay, let me again zoom in. See, if I am at this particular cell. Okay, okay, let me take something in the middle. Okay, this particular cell. Okay, there are many ways to reach here. But once I reach here, okay, what will the next move is very very clear. Okay, why? Because see, when I'm at this 9, the next move will always be to the element greater than that. Okay, that I can know from the the adjacent cells to it. So I don't have to depend on the source of how I am coming to 9. But once I'm at 9, what are the possibilities of moves possible? That is very clear. Okay, so I'm trying to break the bigger question into a smaller sub problem. Okay, that is, if I'm at each of these particular elements. Okay, let us say this, or let us say this. What will be the best move possible for me? Once I have that best move possible, I can simply go to the backward side. Okay, that is, I can travel backwards. For example, I am at this particular cell. Okay, 13. What are the next moves possible? Okay, I cannot move to 11. I cannot move to 15. Okay, I can move to 15. So only this particular move will be have. So whenever I am at 13, I will have to move to 15 only. Okay, so the idea can be, whenever I am at 13. Okay, the number of moves possible, okay, after that will be always one. That is as simple as that. So that is what I'm going to capture in my DP array. Okay, for example, okay, let me take this particular example of okay, 2. So when I'm at 2, okay, what are the possible moves? See, I can go to this 4, or I can go to this 4. Okay, there are two moves possible. Similarly, now what I will do, I will simply take the DP value of these two, okay, and add one to it and keep it here. Okay, see, that is what I'm going to do. But how to get the DP value of this again is a problem. What I have to do, see, I'm starting from 4. Okay, what are the next moves possible for me? I can't go to 3 because it is less than 4, but I have to move to 9 because it is greater than 4. Okay, so the only possible move for me will be to move from 4 to 9. Okay, 2 from 4 to 9. So DP value of this particular 4 will be DP value of this particular 9 plus 1. Okay, DP value of this will be DP value of this plus 1, which is 2. Okay, here. Now when I would 9, how to move? So I cannot move to 5 because 5 is less than 9. Similarly, I cannot move to 3 because 3 is again less than 9. But I can move to 11 because 11 is greater than 9. So whenever I am at 9, there will be only one move which will be taking me to 11. Okay, so the DP value of 9 will be the DP value of this particular cell. Okay, DP value of this particular cell will be DP value of this plus 1. Okay, by now you would have already guessed that whenever I am at a cell of the last column, there are no moves possible. That is, always the value will be 0. That is, for any element of the last column, the DP value will be 0. This is going to be our base condition. From there we will be proceeding further. Okay, that is what I am going to do. So for any other element, what I have to do, I have to simply check whether this particular, that is the possible elements, are anyway greater than or that or not. Okay, the three adjacent element, that is the three moves that we have discussed here. I have to go to them in the grid and check whether they are greater than the current element or not. If they are greater than them, simply take their DP value and add one to it and keep storing here. Okay, that is, if three moves are possible, all the three options you have to consider. Okay, take the DP value, whichever is bigger one, take that, add one to it and store it here. As simple as that. Okay, that is the basic idea. So, okay, let me reduce the zoom now. Coming to this question, what I'm doing is here, I think you will be knowing by now. I'm creating a DP array of exact same size as that of the given matrix to me. Okay. Now, since I will be starting from the last column, okay, that is, remember, the DP value of the last column will be 0. So basically, the real processing will start from the second last column. To start from second last column, what index I have to take? I have to take call minus 2. That is the number of columns minus 2. That will be the index for the second last column. Remember, index, that will be the index for the second last column. Okay, that's what I'm doing it here. The answer, I'm starting with 0, because remember, if you see here, the if nothing works, you have to return 0. In, I think, yesterday's problem, we have to return -1. So we cannot return 0 in that case. We have to add another condition at the last, that if the answer is 0, you have to return -1 in the yesterday's question. But in today's question, there is no such need. Okay, so this particular loop will work till column is greater than -1. That is till column, that is I have to process even till index 0. Okay, that is the first column. Till then it will work. Okay, what I'm doing here, see, my processing is very simple. Okay, for the second last column, I will go through each element of it. That is, I will go to 3, I will go to 9, I will go to 2, I will go to 13, and I will find the d values and I will populate them. Similarly, then I will go to a column backward. That is, I will go to this particular column, 4, 4, 4, 9. I will start from the first one, that is 4, 4, 4, and 9. Similarly, I will go one column back. That is now the first column. Here again, I will start. That is 2, 5, 3, and 10. Like this, I will be proceeding. Okay, so that's why I am starting a loop now. Okay, this loop will start from 0 to the number of rows that we have. That is, if I'm at 5, then 3, then 11, then 15. That is number of rows that we have. Okay. So what I'm doing, I'm, simply for your, for you to imagine it very easily, for you to, remember it very easily, I'm using I comma j. Okay, because it's very, very popular here. Okay, whenever we are using a matrix, we are, very much used to I comma j. Okay, so I'm storing first of all the given indexes in form of I and j. Okay, I'm starting a max value which is equal to 0. So for all the three possibilities, see, this is one possibility. Okay, this is one possibility, this is second possibility, and this is the third possibility. Okay, there are three possibilities. What I'm doing, for each of the possibilities, I am, storing them in x comma y. Okay, what are x comma y? So remember, in all the three cases, it will be always j plus 1 only. Okay, as I have told you already, because always we have to move one column forward. Okay, but this can change. Here it will be I minus 1, it will be I plus 1, and here it will be I as it is. Okay, I'm storing them in x comma y. Okay, x is the, x coordinate, y is the y coordinate. Okay, what I'm checking, first check the x constraint is within our grid or not. The x should be less than the row, that is the number of rows that we have, and x should be greater than equal to 0. Okay, similarly, for same, check for y constraint. Okay, y condition, that is the y coordinate. Then one important part, the grid of x comma y, that is the column that we are, that is the cell that we are going to move. The value in that should be greater than the value of current, that is the current value, and that is grid of I comma j. Remember, we are at I comma j currently. We are at I comma j currently. Okay, it should be greater. If that is greater, this becomes one of the options for us to move. Okay, what we have to do, very simple. Okay, what we have to do, dp of x comma y, you have to take. What is x comma y? X comma y is a target element. Remember, we have to go to that from the current position. Okay, we are in the second last column, we are targeting to go to the next, that is the last column. What you have to do, dp x comma y, take as it is and add 1 to it. Okay, and do this, what I'm doing it here, take the previous value of max and take the current value of dp of x comma y and add 1 to it. Whichever is greater, store it in max. Okay, same thing I'm doing in all the three cases. Again, same thing here, again same thing here. Okay, only thing which is changing is this particular condition. Okay, this condition here, this condition here, these things are changing, that is the coordinates are changing. That is, I'm considering all the three possibilities, but this will be fairly the same. Okay, this is exactly same as this. Okay, because in all the three cases we have to do exactly the same thing. Okay, at last, at the max. Okay, at last, after doing all the three, the max will be the maximum value out of the all three possible options. So if max value is greater than 0, okay, what I have to do, remember one thing I did not tell you, that this dp matrix I'm initializing with 0. All elements initially will have 0. That's why, if you have the doubt why I'm not starting with the last column, but I'm starting with the second last column, because last column anyway it will be 0 only. Okay, I don't have to do anything for it. If you see the tracing here, the last column values of the dp will always be 0. Okay, by default, when the matrix created, that time itself it is 0. I don't have to make that explicitly. Okay, so what I'm doing, if dp value is greater than 0, dp of I comma j is equal to max. Okay, this part, you need not focus on it now. This is just optimization. What here I'm doing is, finally, while returning the answer, what you have to return, the dp value, that is the highest dp value of the first column. Okay, that is when j is 0, that is when we are in the first column. While exploring that, okay, just store the biggest possible answer, dp value. Okay, biggest possible dp value, store it in answer. That is, answer is equal to max of the previous answer, comma dp of I comma j. That is the current value that we have calculated here. Okay, this is the current value. You can ignore it for now if you're not able to understand it, but remember, finally you have to return the highest dp value in the first column. Okay, that is this particular column. Okay, these values, whichever is the highest, that will be the answer. Okay, so that you have to return. So here you have to return the, basically, the max value of the first column's, max dp value of the first column. So instead of doing a loop here again, okay, instead of doing another loop here, what I'm doing is, while I'm traversing this itself, what I'm doing, if I'm at the first column, simply store, that is, check if the particular dp value is greater than any other answer. If it is so, then change the answer to this. As simple as that. Okay, Once this thing is processed, that is once I have done with a particular column, I will reduce the column. That's I will go to one column behind that. Okay. For example, I have done for the third column, I will go to the second column then. Okay. This will run till I am done with the first column, that is the zeroth column. Then the column will be -1. Column -1 is, that is -1 greater than -1 will be false, and I will be coming out of this particular while loop. Okay. I will be coming out of this while loop. Then I will be printing the DP array, and I will be returning the answer. Okay. Let me quickly run this, and then I will show a dry run for the first example. Yeah, if you can see, it works. In when you are doing it, you will have only two test cases here. This is third test case that I've included for a bigger value. Okay, for a bigger value. This was not there initially. So this is the first example we have. Okay, and this is the DP value of that. Okay, I will just show you how it works. So what we are doing here, remember, first thing is all the values, DP values, okay, of the last column should be 0. Okay, because there is no move possible from that. By the way, what is DP of I comma j? DP of I comma j is from starting from that particular cell, how many moves are possible. Okay, how many maximum moves are possible, as simple as that. Okay, so when I'm in the last column, no such move is possible. Okay, when I'm at 3, what are the possible options? I can go to 5, I can go to 3. Okay, so I have to take the DP value of 5, and DP value, that is DP value of the value of the cell in which currently 5 is present, and add 1 to it. Okay, here initially 0 is there, so you have to add 1 to it, it becomes 1. Similarly, you can take the DP value of this also, that is 0, add 1 to it, and store it here, as simple as that. Similarly, for all the elements of the third column, okay, you will get the DP value as 1. Okay, remember, the third column's DP value cannot be greater than 1, because when you are at the second last column, there is only one column for you to traverse, so it will be always 1. Okay, similarly, when I'm at this particular, that is the second column. Okay, when I'm at 4, what are the possible options for me? I can go to 9. Okay, I cannot go to 3. Remember that. I cannot go to 3 because 3 is less than 4. Okay. Similarly, when I was in 3, I cannot go to 3 again because 3 is not strictly less than the current value. I can go to only 5. Okay, remember that. So when I'm at this particular 4, what I have to do? I can go to 9. Okay, but I cannot go to 3. I can go to this 9. Similarly, when I am this particular 4, where I can go, I can go to 9. I cannot go to 2. I can go to 13. Okay, so take the DP values of this, that is the DP value of this and DP value of this, add 1 to it, and store it in the current DP value, that is this. Okay, so you will realize that whenever I'm in the second column, okay, the DP value cannot be more than 2, because there are only 2 more columns left, right? So it can not be more than 2, it can be anything less than that also. Okay, yeah. Next, we are in the first column. So I am in the first column. What are the possible options for me to move when I'm this particular value? 2. I can go to 4. Okay, I can go to this particular 4 also. Okay, these are the two options. So you have to take the DP value of that, add 1 to it, it becomes 3. Similarly, take the value of that, add 1 to it, again becomes 3. So you have to take the max possible value here. That's why you see, we're doing this max thing. Okay, among all the options possible, you have to take the max value. In this case, it will be 3 only. Okay, now when I'm at 5, what are options possible? Remember, I cannot go to this 4, I cannot go to this 4 because they're less than 5. I cannot go to this 4, I cannot go to anything. Okay, that's why the DPL of this will remain as it is when the DP matrix was created, that is 0. It will remain 0. Okay, so now coming to 3, what are the options possible for me? I can go to this 4 because it is greater than 3. I can go to this 4 because it is greater than 3. I can go to this 9 because it is greater than 3. So I have to take the DP value of this thing, this thing, and this thing, and add 1 to it, it becomes 3. Okay, when I'm at 10, what are the options possible for me? Remember, I cannot go to 4 because 4 is less than 10. I cannot go to 9 because 9 is less than 10. So there is no option possible. So it will be, as it is what I created at the time of the initialization, it remains 0. Same value will remain here. It will not change. So as I told you initially, there are two answers possible. Okay, 2, 4, 9, 11, and one more answer is starting from this particular cell. That is starting from this particular 3. You can go to 4, you can go to 9, and you can go to 11. That is again another answer. But anyway, there is another, you can say, uh, way, that is another way. Okay, but remember, since answer is 3, this also answer is 3. So yeah, the max possible moves in this particular example one is 3, as simple as that. That is just another path, I can say. Okay, this was the analysis of example 1. Let me quickly run this and show you. I can provide this dry run, in the comments also if you need it. But anyway, this was the first approach. This is not optimized approach. You will get to know why. Because see here, if you see, initially you will not get to know this, but when you design this code, okay, after watching the video, just try to see this code. I will give this in the comment section. What you will realize is that always, I am looking for one column ahead. That is, when I'm in the second last column, I'm looking for values in the last column. Similarly, when I'm in the second column, I'm looking for values in the third column. That is, I always need values one column after the current column. Okay, but I don't need any other values. So that is the reason why we need not take a matrix of the same size that of the given grid to us. Okay, that is not needed. I just need one column ahead of the current column in which I'm processing the elements. Okay, that is not needed. This leads us to the idea that we can have optimization. Okay, which I have done it here. So what I'm doing it here this time, if you see here, no, here I'm using a 2D matrix, okay, but here I'm not using 2D matrix. I'm using a single matrix whose length is same as the number of rows that we have. Okay, for example, here we have 4 rows, so here it will be of the range 4. Okay, here also, but one thing is common, that all the values initializing will be 0. They all will be starting with 0. Okay, so here what I'm going to do, for whenever I'm going to process a particular column, before starting the processing, I will create a dummy dp column. Okay, I will call it as dp of 1. Okay, again it will be having all the elements of value 0. Okay, at last what I will do, once I have see this, will I will treat as my current column. Okay, this I will treat as my column which is next of the current column. Okay, that is, this is my current column, this is my, this is the dp value of the column which is next to it. Okay, so at last what I will be doing, I will be transferring all the values that I have in dp1 to dp. Okay, now dp, see, idea is, see, when I'm done with processing the third column, okay, I have to go to second column. So for when I'm in the second column, what I have to do, I need to get the values of the next column. So in that case, dp1 will be becoming dp now, and for that particular relation, again dp1 will be initialized with 0. That is the basic idea here. Okay, so dp is matched with 0 as it is. Column, I'm same thing, these are all same what we had in the first solution. Okay, this is also same, this is only addition here. Okay, and the other addition which you will see is here. Okay, here I am using dp of x plus 1. Here I was using this thing, dp of x and y. Okay, remember, I have just removed this particular y here. Okay, why I have removed this particular y? Okay, dp of x plus 1. Okay, similarly here, wherever the y was present, those things I have removed. Remember, this condition remains still the same, because anyway you have to compare the elements, you have to only go to the elements which are bigger than the current element. Okay, that remains the same, but only thing is, now because dp is a single dimensional array, that is 1D array, you have to take the dp of x. Okay, as simple as that. Previously I was taking dp of x and y. Okay, that I am just not doing it now. Okay, dp of x and y you have to take, I have to add one to it, and so written max. This particular max, once it is done, you have to assign it to dp of 1 of I. Okay, here what I was doing, here I am doing dp of I of j. Okay, there I'm storing the max value, but here what I'm doing, in the dp1 of I, I'm storing the max value. Remember, dp1, not the actual dp. Here I'm using dp, that is the next column, the next column, here also the next column, but in this case I'm storing this value in the dp of 1, which is the current column. Okay, at this, again this is the same, only thing is here I'm using dp of 1. Okay, once done, what I have to do, transfer all the values in dp1 to dp, because in the next iteration dp1 will be again reinitialized. Okay, once this is all done, the answer will be calculated. How answer is calculated? Here, whenever I'm processing the first column, I will try to capture all the values of the dp in that particular column, and whichever is the max, I will take that and assign it to my answer. If I can quickly run this and show you, as you can see, this works. Even for a bigger test case, it works. Okay, this is the biggest possible test case in this particular question in Leetcode. I've taken this from Leetcode only, by the way. Yeah, that is, this is the big optimal solution here. If you see in the previous solution, we were using a dp array full. Okay, a 2D dp array, so the space complexity here was O of m into n. Okay, and again we are processing, because column by column, we are processing, for each column we are processing all the elements in that. So it was space complexity also of m into n, time complexity also O of m into n. But here what we are doing, here I am going to use a simple, that is 1D array extra. Okay, so here the time complexity will be reduced to O of n. Okay, here, or time complexity, sorry, the space complexity O of n, but the time complexity will still remain O of m into n. Why? Because again we are processing. Okay, for each column we are processing all the elements like that. Okay, so it will again O of m into n only, but the space complexity got reduced because of this. So this is optimization. And by the way, whenever you solve a solution and you segment it, LeetCode gives you the option of viewing the space and time complexity of it. Okay, for one time. If you're not a premium user, you can check that out for this solution. You will see that it is, the space complexity is O of n. Okay, what is n, by the way? N will be, the length of, that is the number of rows present, that is n I am referring to. Okay, m is the number of other way, that is number of columns. So that is all it is. So friend, that was all for today. This was a nice question. Why I'm telling is because, see, you can solve it in many ways. I showed you the dp way. Even without dp way you can do it. How you can do it? See, you can start from the starting element itself and you can process all the ways. What will happen is, you have to repeat some of the calculations. without, if you are not using DP, you have to repeat the calculation. But the advantage of DP is that for each sub problem, okay, instead of solving it multiple times, we are saving the answer to that, so that whenever we reach it again, we can simply utilize the answer as it is without solving it again. That is the advantage of DP. But with that, the space compression increases. That is the disadvantage here. So we try to make optimization in that, and currently we have reduced the space that we are using to a single 1D array, okay, instead of a 2D array, and that helped us, okay. While submitting the solution, you can see the time complexity, that is time taken for this particular code and the previous code. And again, as I mentioned, if you are not a premium user, you will get one chance to see the space and time complexity of a given solution. Okay, you can try that also. For this particular solution, the space complexity will be open. So Yafan, that was all for today. This was a really nice question. Let me tell you this very frankly. If you are, setting in, let us say, 5 to 10 interviews, maybe like slightly more than that 20 to 30 interviews, definitely take it from me, this will be one of the questions, or at least something near to this will come, where you will be having a matrix and a DP, and a similar approach will be needed of you. That is, you have to for each subproblem you have to save the result, and for other, whenever that subproblem comes, you have to utilize that result. That is the idea of DP, and you have to use that and get the answer. Here there are a lot of optimizations possible, and we have done one of that. This is very popular among face-to-face interviews. I'm not talking about the online assessment. Okay, among face-to-face interviews, this is very, very common. So yeah, fun, that was all for today. If you like my efforts, please do consider subscribing to my channel. It takes a lot of efforts to make this video every day and the best possible way, and do the all the dry runs and show you this. So yeah, fun, that was all for today. Happy Diwali if you're from India. Happy Diwali to you and your family. Stay tuned. See you tomorrow.